Travel is the only thing you buy that makes you richer. From Anonymous. In this lesson, we're going to determine and interpret cumulative frequency. We're going to determine and interpret relative frequency. We're going to determine and interpret relative and cumulative frequency. We will model a situation using a spreadsheet, and we will determine and interpret percentiles. All to answer the question, what will it cost to get there? Before we begin, let's make sure we're ready for this lesson by taking a look at warm-up number 2. What percent of 40 is 8.2? Well, 40 is the total number, and 8.2 is what we have. Since we're going to be turning this into a percent, we're going to multiply by 100, meaning that 20.5 is the percent. Now, 66 is 55% of what number? We can do this by dividing 66 by 55% as a decimal, which would be 0.55. And when we do that, we're going to get 120. So 66 is 55% of 120. Now let's write a literal equation that represents x percent of z to y. This will give us y is equal to x. Since it says percent, we would need to divide that by 100 to turn it into a decimal, and then multiply it by z. Now, let's take a look at a problem that you will be able to do by the end of this lesson. Most cities have some form of taxicab service for short distance trips. Usually, the cab fares are either a flat fee for a specified distance or a metered fee. The metered cabs often start with an initial fee and then charge a fixed rate per fraction of a mile driven. In many cities, wait times and the number of stops often affect the fare as well. The website taxifarefinder.com offers a ranking of cities by the cost of a hypothetical taxi trip to a given duration and distance. Of the top 80 most expensive cities, these are the initial cab fees in ranked order. What is the percentile rank of a $3 initial cab fee? We can see that there are 8 in each column, meaning that we have 80 in total, because there are 10 columns. If we count up all of the fares that are $3 or less, we get 56 out of the total 80 available. So 56 divided by 80 times 100 to turn it into a percent will give us 70. The percentile rank of a $3 initial cab fee is 70%. This means that 70% of the initial fares listed are at or below $3. Examine the following facts reported by the U.S. Department of Transportation and U.S. Travel Association. Over 300 million U.S. residents use some form of transportation each day. There are 128.3 million commuters in the United States. 3.3 million people travel at least 50 miles to work one way. The net income of all U.S. airline carriers for the recent year was $18,922,412,000. Spending by travelers in the United States averages approximately $2.5 billion a day, $104.2 million an hour, $1.7 million a minute, and $28,333 a second. A travel expense can either be essential or discretionary depending on the situation. Commuting costs for getting to and from work are essential. Airfare for flights to a beach resort would be discretionary. The Bureau of Transportation Statistics conducted a survey to gather information about long-distance travel during the summer in the United States. They defined long distance as a trip of 50 miles or longer, and summer travel as a trip taking place between Memorial Day weekend and Labor Day weekend. In a particular study, they gathered data on over 650 million long-distance summer trips in a single year. Examine the frequency distribution that illustrates the number of trips according to one-way distance from home. At a distance, you would easily be able to identify the number of long-distance trips for any of the 4 mileage categories. But what would it take to answer these questions? How many of these trips were less than 1,000 miles? What percentage of trips were greater than or equal to 500 miles? While the computation is not difficult to do, this lesson introduces you to two variations of the frequency table, known as a cumulative frequency table and a relative frequency table. Each of these will extend the information given in the basic frequency table that we learned in the last lesson, so that questions like those above can be easily answered. Here we're going to learn to interpret and construct two new tables as we examine vacation travel and vacation travel expenses. Let's determine and interpret a cumulative frequency. How many of the trips listed in the summer travel table or frequency distribution table that we can see on the screen were less than 1,000 miles? In the summer travel table, the column labeled number of long-distance summer trips is the frequency. Those numbers were compiled by sorting the length over 650 million trips into 4 mileage categories. To answer this question, you need to add a new category to the table that lists cumulative frequency. This column is created by keeping a running total of all frequencies that are less than or equal to the frequency of that particular interval. The new table is known as a cumulative frequency table and looks like this. The cumulative frequency in this table tells the reader the number of trips that are less than or equal to the longest distance in the interval. The number of trips less than 1,000 is the sum of the frequencies of the first 3 rows. This is the cumulative frequency for the interval 500 is less than or equal to m less than 1,000. There were 617,580,000 summer trips taken that are greater than or equal to 50 miles and less than 1,000 miles in length. Let's check your understanding and see how many trips were less than 500 miles. We can see that it is 584,730,000. Now, the Flyt Travel website reported the following airfare booking expenses for the week of July 4th. What proportion of the tickets sold had a cost greater than or equal to $400 and less than or equal to $499.99? To answer this question and questions related to it for other intervals, you should create a new column to indicate relative frequency. Relative frequency is the ratio of the frequency of a particular interval of the total number of pieces of data collected. The relative frequency represents the proportion of the data that falls in a particular interval. It is expressed as a decimal rounded to whatever degree of accuracy is needed. Relative frequency can easily be written as a percentage. The relative frequency formulas are given here, where RF is the relative frequency and F is the frequency and N is the total number of frequencies. So RF would be equal to F divided by N. Relative frequency is expressed as a percentage, which means multiplying by 100. It should be noted that RF is its own variable in this case, separate from F. Now let's determine and interpret a relative frequency. To set up a relative frequency table, add a new column. The total number of frequencies represent the total number of bookings reported by Flyt Travel. The sum of the bookings listed in the table is 1,434. Use this to determine the relative frequency. So the R being 70 and the N being 1434 will give us 0.049. And 120 divided by 1434 will give us 0.084. We would continue this with all of them all the way down. Ideally, the sum of the relative frequency should be 1, but you may get a number very close to 1 because of some rounding. The relative frequency for 400 to 499 is 282 divided by 1434 times 100, which is 19.7%. So this represents 19.7% of the total number of bookings reported. Now we can do this on a computer in a spreadsheet. In the B12 cell, we will put equals sum, open parenthesis, B2 colon B11, close parenthesis, and hit enter. to get 1,434. To calculate relative frequency in the C5 column, we will put equals B5 divided $B $12 and equals. Now what that $sign is doing as it surrounds the B is it's not gonna move. That's gonna stay the same. If we wanted to do all of the others, we would simply copy that cell with Control C, highlight the cells we want it to go into, and Control V to place it in. Let's check our understanding and say what percentage of the total number of bookings fall within the range of 700 to 899. So 700 to 799 gives us the 136. 136 divided by 1434 times 100 will give us 9.5%. And the 800 to 899 will give us 80 divided by 1434 times 100 is 5.6%. So 9.5 plus 5.6 will give us 15.1%. This represents 15.1% of the total bookings. A spreadsheet is an electronic worksheet that can be used to explore, manipulate, analyze, and interpret data. Spreadsheets allow you to enter data into columns and rows. The intersection of a column and row is a cell. Cells can contain numbers, words, or formulas. While the structure of a formula can differ based on the software, formulas have a fundamental algebraic basis. In spreadsheet formulas, you use an asterisk for the multiplication symbol and a / for the division symbol. You do not use spaces around symbols. Now examine this spreadsheet. It contains all of the data from the frequency table in example 2 with the added row labeled total. All entries in cell A1 through A12, B1, and C1 are rows and columns labels. The entries in cell A1 through A12, B1, and C1 are rows and column labels. They are not mandatory in a spreadsheet, but they help to make sense of the data. It is important to recognize that cells may contain numerical labels such as the ones in column A, but those cells cannot be used for numerical calculations. The frequencies in cells B2 through B1 have been input by hand. All of the other entries have been calculated using spreadsheet formulas. The entry in cell B12 is the sum of the frequencies in cell B2 through B11. A formula can be stored in cell B12 to calculate the sum if B12 represents the sum equation needed is B12 equals B2 plus B3 plus B4 plus B5 plus B6 plus B7 plus B8 plus B9 plus B10 plus B11. You enter the right side of the equation into the cell beginning with equal symbol as shown on the screen. Spreadsheets have built-in formulas to save time. The long sum formula can be replaced with the formula equal sum open parenthesis B2 colon B11 close parenthesis, where B2 indicates the cell for the first entry of the list, B11 indicates the cell for the last entry in the list, and the colon indicates to add the cell entries B2 through B11. You can see how this would make a formula entry for a sum a lot easier, especially if you're working with a very large data set. The entries you see in cell C through C11 have not been calculated by hand. For example, a formula has been entered into cell C2 that determines the relative frequency. That formula is equal B2 divide $B $12, the frequency divided by the total. The formula in cells C3 through C1 are similar to this one. Depending on the program you're using, you can set the number of rounded places for each cell according to the degree of accuracy needed in your calculation. Be aware that the computer retains the entire calculation to many decimal places. In this case, it just shows the value to 3 decimals. Now, let's model a situation using a spreadsheet. Let's write a spreadsheet formula that would find the sum of the relative frequencies and enter the calculations amount in C12. To find the sum of the relative frequencies listed in cells C through C11, you can enter equal capital S, capital U, capital M, open parenthesis, C2 colon C11, close parenthesis, and hit enter. Now let's extend your understanding and suppose that you wanted to add a fourth column that expresses the relative frequency as a percent. What formula would you enter into cell D2? We would put in equal C2 asterisk 100 and hit enter. Now let's determine and interpret cumulative frequency. Let's extend the relative frequency that we saw previously to determine the percentage of Flyt Travel bookings that are below $600. The relative frequency column only gives you the information for one interval. To answer this question, you need to calculate the cumulative frequency and the relative cumulative frequency. The relative cumulative frequency is the ratio of the cumulative frequency of a particular interval to the total number of the pieces of data. The relative cumulative frequency are given here, RCF. Now that's going to be one thing together, not different variables being multiplied, as the relative cumulative frequency, and CF as the cumulative frequency, and N as the total number of frequencies. So the cumulative frequency, as we add them going down, we get now 70 plus the 100 for 190. The 190 plus 310 for 500. The 500 and the 282 for 782. And so on until we get 1412 and 22 for 1434. This gives us the cumulative frequency column. Now to calculate the relative cumulative frequency, we're going to do the cumulative frequency divided by the number. So 70 divided by 1434 will give us 0.049. 190 divided by 1434 will give us 0.132. And 1434 divided by 1434 is 1. Now look across the row labeled 500 to 599 to the relative cumulative frequency column. This number represents the proportion of bookings that cost less than $600 or at or below $599.99. Relative cumulative frequency is 0.662. This shows that 66.2% of the bookings cost less than $600. Let's check our understanding of this and say, what does 0.545 in the relative cumulative frequency column represent? It means that 54.5% of the fares were at or below $499.99. Let's extend our understanding of this further and round to the nearest whole number what percent of bookings fell between $700 and $999.99. So we have 136, 80, and 96. We're going to do a 100 times 136 plus 80 plus 96 dividing by 1434. To get 21.8%. Now that would mean 22%. Let's take a look at some percentiles. Recall the median of a data set. The median is the middle score if the number count is odd, or the average of the two middle scores if the number count is even. It divides the data into two equal parts. Since the median is the middle, 50% of the data falls above it and 50% below it. Rather than divide the data into two parts, suppose you divided the data into 100 equal parts. Each part is known as a percentile. Unfortunately, there isn't a complete agreement on the definition of a percentile. Rather than offering and using all of the possibilities, we will stick with the following. A percentile is a statistical measure used to compare data. It indicates what percent of the frequency total appearance at or below a particular number. A percentile rank is the percentage of numbers that fall at or below a given number in this list. The median is often referred to as the 50th percentile. Percentile ranks are usually written to the nearest whole percent. Here you learn how to calculate percentiles. So let's determine and interpret a percentile. Most cities have some form of taxicab service for short distance trips. Usually the cab fares are either a flat fee for a specified distance or a metered fee. The metered cabs often start with an initial fee and then charge a fixed rate per fraction of a mile driven. In many cities, wait times and the number of stops often affect the fare as well. The website taxifarefinder.com offers a ranking of cities by the cost of a hypothetical taxi trip to a given duration and distance. Of the top 80 most expensive cities, these are the initial cab fees in ranked order. What is the percentile rank of a $3 initial cab fee? We can see that there are 8 in each column, meaning that we have 80 in total, because there are 10 columns. If we count up all of the fares that are $3 or less, we get 56 out of the total 80 available. So 56 divided by 80 times 100 to turn it into a percent will give us 70. The percentile rank of a $3 initial cab fee is 70%. This means that 70% of the initial fares listed are at or below $3. Let's check your understanding and determine the percentile rank of an initial fee of $2.85. Well, with 8 in each of the 3 columns, that means there are 24 in total. Of the 80 total cab fares, multiplying that by 100 gives us 30%.